All right, this is our second lesson on radicals. We're simplifying radical expressions. So we'll start out nice and easy. Square root of 121 is 11 because 11 times itself equals 121. Cubed root of negative 64 equals negative 4 because negative 4 times itself 3 times is negative 64. And the fourth root of 81 is 3 because 3 times itself 4 times is 81. Perfect. All right. I'm going to fill in this. I'm going to ask you to fill in this chart below, and I'm going to fill it in at the same time while this is paused. So please pause the video and fill in the chart below. All right. Hopefully you've paused the video and filled in that chart. So let's have a look here. So we know from yesterday that the square root of x squared is the absolute value of x. And we can see that because the square root of x squared is always positive. Okay, how about the cubed root of x cubed? Well, if x starts out negative, it stays negative. So the cubed root of x cubed is just x. Fourth root of x to the fourth. Again, we've got x to the fourth makes it positive. And then we take the principal fourth root, which is always positive. So that guy's always going to come out positive. And then odd is going to be x to the fifth. Stays negative. So when you fifth root it, it's also negative. All right, example 1 from the book. We've got 9 root 2, 2 root 6, and 8 root 3. Easiest way to put these in order from least to greatest is to put them into entire radicals. So 9 root 2 is the same as root 81 times root 2. 2 root 6 is the same as root 4 times root 6. And 8 root 3 is the same as root 64 times root 3. So that gives us root 162, root 24, and root 192. So smallest, second smallest, largest. B is really easy because these are all cubed root 3's. So this one I've only got 3 of them, so that's the smallest. This one I've got 7 of them, that's the second smallest. And that one I've got 8 of them, so it's the largest. Alright, C, because these are all different roots, this is a square root here, there's nothing we can do algebraically to compare these. So the best thing to do is just punch them into our calculators. This one we get about 8.8, this one we get about 9.0, and this one we get about 8.9. So smallest, second smallest, largest. So example 3 from the book, we want to talk about what values of x are going to be okay and which ones aren't. So let's say I were to put in 1 for x. So that would give me the square root of 54 times 1 cubed, which is root 54, which just equals root 54. So that's fine. I can take the square root of 54. If I try to put in negative 1, that would be root 54 of negative 1 cubed. Negative 1 times itself 3 times is still negative 1. So that would be the square root of negative 54. Can't do it. So we're going to have issues if x is negative. So we need to say that x is greater than or equal to 0. Okay. In part B, if I were to put in negative 1, so clearly 1's okay because I'd have the cubed root of 12. If I were to try a negative 1 to the power of 5 in here, that would give me the cubed root of negative 12, which is fine because we can have a cubed root of negative 12. So x can be anything, any real number, so we can say x is an element of the reals. Alright, so let's have a look here at 4a. And the first thing we need to do is figure out for what values of a is this thing going to be defined. Well, it doesn't matter what I put in for a. Even if I put in a negative, it's going to get squared to a positive. So I can put in any number for a. A just has to be a real number. Okay, and now a good way to think about this is this is the same as root 75 times the root of a squared. Root of 75 is 25 times 3. So that's going to be 5 root 3. And then times the square root of a squared is the absolute value of a. Because no matter what I put in there for a, it's going to come out positive. So normally we'd write that as 5 absolute value of a root 3. Okay, part B, I've got the square root of 18b to the 5th. On this one, if I put in a negative for b, it's going to be an issue because I'm going to end up with the square root of a negative number. So b is going to have to be 0 or more. Alright, and again, let's rewrite this as the square root of 18 times the square root of b to the 5th. 18 is 9 times 2, so that's going to be 3 root 2. And b to the 5th, you can think of as b times b times b times b times b times b 5 times. So I got 2 sets of b squared. So that gives me, that's going to be times b squared root b. And to clean that up, I'd end up with 3b squared times the square root of 2b. Alright, C. Because this is a cubed root, it doesn't matter if what's inside is positive or negative. So x can be anything. And that's going to be the same as the cubed root of negative 15 times the cubed root of x. Well, 15 is just 3 times 5. So I don't have 3 of anything in there. So really, there's nothing I can do with this. If I wanted to, I could pull the negative outside. That's pretty much it. Alright, D. D again. This has to be positive on the inside because it's a 4th root, which means that E has to be positive. 80 is going to be 2 times 2 times 2 times 2 times 5. Which means I can pull a 2 out. Oh, sorry. I missed a 2 there. 2 times 2 times 2 times 2 times 2 times 5. Or is it? No. No, it's going to be 8 times 10. Yeah, sorry. I did it right the first time. So I need to pull all of these 2's out to give me 2 4th root 5. And then the e's, I've got 7 of those. So I'm going to be able to pull 4 of those out. And I'll be left with e cubed on the inside. So to clean that up, it'd be 2e 4th root 5e cubed.